Now we are going to discuss the shifting theorem, where you are having time delay and time advance functions, where z transform of x of t minus nt, which is a time delayed function, the z transform of this is given by z power minus n x of z, and the z transform of x of t plus nt, you have z power minus n into x of z minus sigma k is from 0 to n minus 1 x of k z power minus k. Now we will have to try and prove these two theorems. Let us see the first theorem. In this case, z transform of x of t minus nt, by definition we have by definition we have this as sigma k is from 0 to infinity x of kt. T can be replaced with kt in the discrete time systems, z power minus k. Now let me say k minus n. Let us say k minus n is m. We can say that let k minus n is equal to m. So replacing this with this, sigma k is from 0 to infinity x of k minus n into t, you can write it as x of mt, and z power minus k. K is nothing but m plus n. Right. So if you have m here, and when I'll have to replace k also with m and n. Therefore, what is k in our instance? In this instance, k is m plus n. M plus n is equal to 0, and because I have x of mt, I will take m as the left hand side and n to the right hand side. Therefore, m plus n is equal to 0 indicates m is equal to minus n to infinity. M is from minus infinity n to infinity, and for all our cases we have considered x of t is equal to 0 for all t less than 0. That is, for all negative values of m. See, m is going from minus n to infinity, indicates m is going from minus n plus minus n minus 1, so on, 0, 0, 1, 2, and so on. So you are going on adding these values. This here you will get plus 1. Then you are going on add this, and for these values below 0, for all values of m below 0, x of mt is equal to 0. X of mt is equal to 0 for all values of m less than 0. That is, for all negative values of m, x of mt is going to be 0. Therefore, without loss of any generality, you can just replace m from 0 to infinity x of mt z power minus m into z power minus n. Now this is considered a function, and z power minus n is no way getting any change in its value when you are replacing m with various values of n. Therefore, you can write this as z power minus n sigma m is from 0 to infinity x of mt z power minus m. Now by definition here, by definition of z transforms, what is z transform? In our case we have taken from x sigma k is 0 to infinity x of kt z power minus k. Here instead of m you have k there. You can see m is from 0 to infinity, and here k is 0 to infinity. X of kt here, x of mt, z power minus m, z power minus k. So without any loss of generality, you can replace m with k. Therefore, you will get z power minus n, and this value is x of z. You get x of z here. So this equation is proved. So a time delayed function z transform of x of t minus nt is equal to z power minus n x of z. This is the property shifting theorem.